Hey guys, I'm gonna try a different camera angle here this time, see if I get a little less glare. Well, I'm back again. We're gonna do some guided practice on area. So we're doing a different type of measurement this time. So instead of finding the distance around the shape, we're actually gonna be trying to measure the inside of the shape. But instead of measuring linearly, the thing you have to remember when you're measuring with area is that you're actually measuring with a square unit. So in the problems on our page, if you haven't already watched the Math Antics video, I got to remind you, please make sure you watch the Math Antics video on area. It's just going to give you a good base foundation. We're going to be working through a couple problems from your area practice today, so click the link. You can bring that up. So if you take a look and study all the shapes at the page, I kind of, as a mathematician, like to take a look at what I'm going to be working with. So in this case, they're all rectangles, or we have a square. So we learned in the math formula from the video was that all you basically have to do is multiply length times width when you're dealing with a square or a rectangle. However, I don't want you just to rely on the formula because the formula is just a quick, speedy way to get the answer. I really want you to conceptualize what it is you're doing. You're finding area. Okay, so let's take a look at the very first one. It's a rectangle with dimensions of 13 inches by 9 inches. So what do we mean when we say we're actually trying to measure the inside of the shape? What we're basically saying is if we had a 1 inch, now this is not going to be to scale, but let's just pretend that I had a square, literally cut one out, that was 1 inch by 1 inch. And you're going to take your square and you are going to try to see how many of those would fit perfectly inside of this rectangle. Now, you could hand draw them. So I could say, okay, here's 1, here's 2, here's 3, 4, and so on and so forth. I'm not the best artist, so I'm not sure, if I'd be able to draw that 1 inch square and lay them all in there and then count them all. It'd be a good way to estimate. But if I wanted to find the true area, I'm better off actually relying on a skill that you actually used in 3rd grade, which is drawing arrays. That would be that you're going to take this whole area shape and actually break it into little squares, and you are going to have 13 rows going down this way and 9 columns going up and down. So just visually, let's see what that would look like. Let's see if I have 1, 2, 3, 4, 5, 6. If I cut them again, 7, 8. Oh my goodness, this would take quite a long time. Let's see if I get my 9 rows. 1, 2, 3, 4, 5, 6, 7, 8. Okay. I don't know about you, but I don't feel like counting all of these squares to try to figure out what the area would be. But I wanted you to let you know that I wanted you to see visually what it is that you're doing. You're basically chopping up this entire shape into little tiny squares and then adding up how many of those square units fit inside the shape. Luckily, mathematicians have figured out an easier way for us to do this. So if you remember in arrays, what that basically means when you make this grid like this, you're basically multiplying the two side lengths. And that's where our formula comes from. Area is equal to the length times the width. And so just remember that your length is always the longest side and your width would be the other side, the shorter of the two. If they are the same size, then you have a square. So I'm going to take a second just to redraw this shape. So we have our 9, 13. Now, I know that I need to multiply length times width. I can start off by multiplying 13 times 9, and I can set up a column problem like we did in school this year. So if you remember from our standard algorithm, we're going to start in the ones place. I'm going to multiply 9 times 3, which is 27. Put 2 down, carry. Sorry, put my 7 down. Carry my 2 to the tens place. And then I multiply 9 times the 1 in the tens place, which is 9. Plus 2 more is 11. So the area of this shape, if I were to draw all of those square units, there would be 117 of those little squares inside of that shape. Boy, I'm sure glad I used multiplication and did not try to add up all the squares. So how do I write my final answer? Well, it's important that you take a look at the unit, which is inches. So my final answer, I would say that A, or area, equals 117. And then I would write square inches in this case, because we were actually measuring in little squares that were an inch all the way around. Another way you might see it written, you could say 117 inches squared, which is written as IN for abbreviation for inches, and then put a little 2 that's kind of raised up, and that stands for square. So that's kind of a shorthand way to write it. So all in all, our area is 117 inches squared. Now, honestly, this is a great way to go. But another cool thing you could have done with this problem, if you want to kind of see it visually, is, and for a lot of our mental mathematicians out there, especially myself, I probably wouldn't have solved it this way. And what I would have done is I would have said, okay, I'm trying to map out all of these squares. I want to figure out 9 times 13, but I want to do it mentally. Well, instead, I would have decomposed 13 into 10 plus 3. So I would have said, well, the length of this line is 13, but what if I broke this part of the line into a 10, and I broke this part into 3 inches, so 10 inches and 3 inches. And what I would have done is I would have said, okay, mentally, I know my 9 times 10 and 9 times 3. I know that 9 times 10 is 90, and 9 times 3, this section, would be 27. So the combined area would be 90 plus 27, and that would also equal 117 inches, or square inches. Okay, just another way to think about it. All right, another kind of trickier one I saw on here again was a little throwback from last week. And it was where we actually had to multiply with fractions. So let's take a look at, at the bottom right-hand corner. We have a rectangle that is 4 inches, has a length of 4 inches, and it has a width of 4/5 of an inch. Okay. So in this case, I'm going to apply our formula. Area is equal to the length times the width. And that means I have to multiply 4 times 4/5. So this is what I'm thinking. I'm thinking in my mind 4 times 4/5. Quick handy tip to remember. I think we get a little intimidated when we see not a conventional multiplication problem. This isn't like a quick fact kind of problem. We just have to rely on what multiplication really is. Multiplication means repeated addition. That means that I am adding, in this case, 4/5 4 times. So this multiplication problem of a whole number and a fraction actually becomes really easy. I'm really taking 4/5 and I'm going to add it 4 times in a row. So remember, when we are adding and we have the same denominator, the denominator stays the same, and I'm going to add up all the numerators. So I'm going to skip count by 4s. 4, 8, 12, 16. So the improper fraction is 16/5. However, we're going to need to convert this into a mixed number. So I'm going to set up my long division problem. 5 into 16. 5 goes into 16 3 whole times. 5 3 times is 15. I'll subtract. I get my remainder of 1. So the area of this shape, remember when we're converting an improper to mixed using long division, remember our answer, our quotient, becomes the whole number. So big 3. Our remainder is the numerator, and our denominator stays the same. Okay? And our unit was inches. Okay? So our final answer, the area of this shape, is 3 1/5 inches squared. Okay. All right. Kind of was doing, I saw this problem. I wanted to show you just kind of a unique way to add this up as well. So I'm going to back up just a step. I really like an addition because I can kind of do whatever I want with the numbers. And that's what's kind of fun about math, is that you don't have to stay locked to some formula or some way of solving from left to right all the time. In this case, in addition, I can add these numbers in any way I want to, and I can also decompose any of these numbers that I want to. So go with me here on this for a second. This is just kind of a cool way to think about it. I noticed that 4/5 is really close to 5/5, which is a whole. And in fact, since they're all 4/5, I know that they only need one more fifth to become a whole. And so I said, well, what if I just took maybe this one right here, this 4/5? And I said, well, 4/5 is really equal to 1/5 plus 1/5 plus 1/5 plus 1/5. Now I'm thinking of all this mentally, but if I were to actually break 4/5 into expanded form and have 4/1/5, look what I could do. What if I decided to add and actually add in a different way? What if I gave these 1/5 to all of these 4/5? Well, what would that mean? Well, let's pass them out. If I combine these two, 4/5 and 1/5, and this last one here, look what happened. I was able to create 1 whole plus 1 whole plus 1 whole. And what did I have left over? I had 1/5 left over. And this becomes more mentally easier for me. That becomes 3 1/5, which is the same answer that we got when we did the long division and we added up the fractions. Now, I know for you, you're thinking, Ms. Schaefer, it'd be a lot easier just for me to do the long division and get the answer. And you're right if you were to copy the exact same steps that I did. However, I don't think it would be faster if you actually were thinking of 4/5 mentally as 4/5 written out into a series of 1/5 added together. The reason it probably felt a little longer was because I was explaining and talking. However, mentally, making all of these wholes, I think would have been a little bit faster. So I just wanted to challenge your mental math thinking a little bit today. Hopefully you find this area video helpful. And as always, if you need help, reach out to me, reach out to your teachers. Okay. We hope you guys are doing well and continuing learning and loving math.